Okay, the variables.
X1 and xi,
Xi.
or
What the Xi indicates?
refused unit of each month.
So since that's time, then we are using as xt to indicate the number of units produced. Any other variable? Holding variable, we call it IT. That's number of units. Unhand. Okay. And because, as always say, we can produce more than 50 units because for someone will be work for that'll be meet for the next period. But actually only tell me how many units to produce. I didn't tell me didn't give me any information of how many how many units on hand. So we need another variable to tell us what happened. Okay. So besides that, we can define some notation.
IT is xt minus 1 and minus 50.
IT is
xt minus 1 and minus 50.
minus 1. Hold on. We will talk about that later. We try to write down the relation between I and xt. So we'll talk about that later.
Why don't we use the Xij, in which I is the one that produce, that the units produced, and J is the end of the period that is.
Yes. We can do that. There's another talk about the formulation. There's only one way to do the formulations. That's what he said. We can use it as Xij to tell us that produce in I and meet the demand in J. We can do that. But you can do that and you try to see how easier to formulate that. Another way is that we try to make the formulation compact. Okay? Maybe they have different formulations, but some formulations complex, some formulations compact. Okay? So actually it really depends. So, you can try a different formulation and to do a comparison. Okay? Notation. Let me to talk about the relation between I and x. That will be in our constraint. So we'll talk about. That's why I say we will talk about that later. Just before we do the formulations, we need to define our variable and notation. So I already defined the variable. Right now I define my notation. The notation will be demands D1, D2, D3, and D4. Okay. And also I suppose, because I don't have any information of initial inventory, so suppose our initial inventory is 0. Okay. So our objective function is try to minimize something. Minimize the net cost. So the cost including production cost. So production cost will be
5x1 plus 8.
5x1 plus 8x2 plus 4x3 plus 7x4. That is production cost. And also inventory cost. Inventory cost would be 2 units on hand, right? So that would be
2i2, 2i1,
I1, I2,
2i3.
I4.
No. Because you can sell and minus 6i4.
I4, actually I4 we will sell that. We'll sell that for $6. Okay? So I will say minus 6 I4. So you don't have it. That's what we say in our previous assumption. We say we want to sell everything at the end of the month. 4. Okay. So constraints. We want to build a relation between I and X.
x1 will greater than
X1 is greater than 50. Are you sure? Yes, it's greater than or equals to 50.
greater than
Greater than or equals to.
and greater and equals to.
Okay, but question is, if it's really greater than 50, how many units will be on hand? Remember that we don't just have X, we also have I to indicate the inventory. So for each period T, let's talk about a general case for each period T. At a period, we have production units, right? We also have our demand, right? Okay? Okay. So think about this case. Let's take an example of period 2. 65. I can only produce 60 units. But how can I fill the 65? Inventory from the previous, right? And to meet demand. Okay? Okay, that's only one example. Okay, let's talk about the other example. I can produce 60 units in the first period. So what happened? 60, 50. We don't have that, right? That's 0. 60, 50, and
Minus what IT?
the rest of them will becomes inventory, right? Okay. So for general case, for each period, I have a production units, I have a demand, and production units, the demand could be filled by our production units all from the previous inventory, okay? Or maybe I can produce more to fill my demand and also for the next period demand or in the following demands. So, is that easier? And actually, you try in the very beginning. You try to write down this kind of general formulation. It's not easy. Okay. So sometimes we have to read a lot of formulation, then we can figure it out what happened. Okay, that will be easy for all period T and all variables greater than equals to 0. That will be very simple formulation, right? Okay. Let's take extension, assume. So right now, we don't just have inventory, we will also have another choice for Pelec. Pelec also says that I cannot meet that. But we know in the future we have a less production cost. So we can production later and fill them. Okay, that's what you learn in the operation management long time ago, right? So again, and how can I formulate that? Right now we have another variables, right? So we have that BT indicates the number of units in Veloc. So we introduce a new variables. And how can I write down our objective function? That will be minimized. Previous production and inventory cost remain the same. Plus 4 for B1, B2, B3, and B4.
Do we have before?
So like this one, B4 probably we don't need that. Okay, you can write that. You also can write that, but one because we only have 4 periods for our decision. And in the end of period 4, we sell everything. So again, you still can write down, but you will find it I4 and the B4 are redundant. Okay? Okay. For formulation, you can write down everything to maintain the integrity of everything. But once we solve it, you will find something we don't need. Okay? So how can I write down the this constraint. Previously, we have I xt equals to pt it. And right now we have a new think about this case. Production. Production can fill demand or becomes inventory on hand. But once we have this kind of scenario, it means that sometimes our production cannot fill the demand. So it becomes better. For example, in the very beginning, I only produce 40. So what happened? The production 40, but that's 50. So 10 becomes our backlog. So how can I represent that? That will become minus. Okay? So actually you can put these two together. My production units could becomes inventory if I produce more than our demand. If I produce less than our demand, it will becomes backlog to fill later. Okay? Okay. So as you can see from the previous scenario, from this formulation, you can find that once we have this kind of relation, we can copy this relation to the previous one. So it looks like okay. And we have this kind of scenario. Okay. When I write down the formulation, you'll find that that's easy. It's nothing hard. But if I ask you to write down the formulation by yourself, you'll find that how can I write it down? So the easiest way is that try to utilize some example. Try to figure it out what happened. Okay, one by one. And try to see the result. Okay? So again, like the previous one, no variables greater than equals to 0. Okay? So this extension, just an example, tell you that I only add one condition. And sometimes it will make the formulation complex, okay, compared to the previous one. Okay, for another example. this one looks similar to the previous one, crude oil to gasoline, but much more complex. Okay. Let me explain. A company has 3 different processes. So process 1, process 2, process 3. They have different running costs. For each hour, the running cost 5, 4, and 1. Okay? And different processes, they have a different input and output. For process 1, BL means the barrels. 2 barrels of C1, 3 barrels of C2. That's the input. And the output is 2 barrels of G1 and 1 barrels of G2. It's gas 1, gas 2. So process 2 is 1 barrels of C1 and 3 barrels of C2 will give me 3 barrels of G2. For process 3 is for gasoline 3. So I need 2 barrels of C2 and 3 barrels of G2 to give me 2 barrels of G3. Okay? And the availability of C1 and C2 is that each week we have 200 barrels and 300 barrels and their cost. And for each G1, G2, and G3, they are the same price. Okay. And most 100 hours of production process. Okay. So how can I define our variables? Again, we can utilize the previous idea, crude oil and gasoline. So based on previous, we have CI and GJ, right? Based on the previous. Again, when we introduce the formulation, it looks like our experience. Okay? So once we already see the previous example, we can just try to check if it is true. Okay? So C1 is the number of barrels. Why do we need that? Because here we have availability. We emboss some barrels. Okay? That is for we can say this one is CI. OUI we can also say that's a CI. And that's for GEJ. So per week, so here I is 1, 2, and J is 1, 2, 3. Okay. So do we need?
I think we need another index of process.
Process, yes. We need process because we have running costs and also we have hours limit. The different process I have to give them a different variable. So we can utilize PK in the case for each process, P1, P2, P3. But how can I define it? number of hours. Number of hours. Okay, so you will find that it's very similar to the previous one, but sometimes very, very different. But still, we can utilize our previous experience CI and GJ. You can do that.
So the objective function is to minimize the cost, right?
Minimize the cost. How about the previous one? Now we have revenue when we sell the gasoline. That's our cost to purchase crude oil. So maximize, so we can say as a maximize revenue, like a previous maximize the profit. Like the previous example. So we can sell the gasoline or I can sell it 9 G1 plus 10 G2 plus 29 G3. That's our revenue. Right? And our cost will be
The production cost.
also production cost, but here we're talking about crude oil first. Like the previous one. So our cost for crude oil is 2C1. And also we have production cost. Production cost will be P1, P2, and P3. Different process that have different running cost. So that will be 5.
4, 1.
Okay. That's the raw material cost, that's the production cost. Okay. Constraints? Let's start from the easiest part. Then we come back to this mixture.
C1 less or equal than
C1 less than or equals to 200. So C2 is less than or equals to 300. Any others? How about this one?
P1 plus P2 plus P3
That's P1 plus P2 plus P3.
less or equal than 1.
Okay? Okay, so right now we need to know how many C1 and C2 we use. Because here we need the number of you. Unlike the previous example XIZ, we can combine XIZ to become a C, I, or GJ. But right now we have a different combination in different process. So we need to know how many C1 we use. For example, C1. The process 1 will utilize C1, and also process 2 utilize C1. So in process 1, also in process 2, we utilize C1. And in each hour, I utilize how many, I need how many C1? 2 for process 1. and 1 for process 2. Right? Okay. So how about C2? C2 will be 3P1 plus 3P2
2P3.
2P3. Okay? Okay. So that's the number for C1, C2, C3. And how about
G2.
G1, G2, and G3? So G1. How many gasoline do we produce?
2P1.
It's 2P1. Here is only for in one. We only can produce G1 in process 1. So how about G2? Two
1P1 plus 3.
1P1. How many P2?
3.
3 P2.
Minus 3P3.
Minus 3 P3. Why?
Because they were using.
That's the input for process 3. Okay? How about G3?
Just 2P3.
2 P3. Okay? Any more? Any more? No, that's all. So, unlike the previous one, that's 1-to-1. How many barrels in usage? How many barrels were produced for gasoline? Right now we have some transformation. We lost some units. Okay, and like the previous one, like the previous example.
为什么是一个 G1 是1/2个 P1？因为一个 P1 应该会做出2个 G1。
P1 是一个 process，P1 是一个 process，也就是说我做1个小时，我可以产生2个 G1。
哦，了解。
所以你一个 G1 是
我们的单位是桶，我们的单位是桶，不是时间。现在我要把时间转换成我有多少桶，我生产了多少桶，因为我上面的数据是根据我卖了多少桶。I will explain in English later， 知道吗？现在的 process 是时间。
嗯。
原本是1:1嘛，就是 G1 跟 P1，然后它现在是你1个小时就可以做2个 G1，所以就会变1:2。
你问我问题，问我问题。
我再想一下。
我要把时间转换成桶了。你要知道，我现在是要把他们单位全部统一。
嗯。
OK， 因为像这个的话，我要全部把它转换成钱的单位 ，objective function。OK， 那这边的话，我把它们全部转换成 像这个的话，全部转换成 ton， 多少 barrel？ Okay. Her question or his question is about what G1 is half P1. Why not? But my answer is that right now we try to unify our units. Okay, so C1, C2, G1, G2, G3 will become barrels, number of barrels we use, we produce. Okay, so for each hour, because the process only indicates number of hours. Okay, so how can I link the hours and barrels together? So I need this detailed input and output. So for example, in 1 hour's process 1, I need 2 barrels of C1. Okay, so I transform from the hour to barrel. 1 hours of P1 need 2 barrels of C1. Okay, we try to do this kind of transformation. Okay. So in the future, your formulation probably have different types of units, and sometimes you need to unify them. Unify them, you need some transformation. So this one looks easier, but actually it's not. It's much more complex compared to the previous one. Okay, this one is much more complex to the previous one. So our formulation will become harder and harder. So any questions? This one? That's in hours, but again, our objective function we talk about is money. Right? Money. So that's the money. We transform barrels to money. Barrels to money. So again, yes, that's our P1, P2, P3 out. Yes, but we transform them to money. So that's a production cost, raw material cost. That's our revenue. Okay. It's a multi-period decision, like the previous inventory and production cost, but we make it a little bit complex. Again, it's a like decision. So suppose we have 10,000 for investment, we can put in A, B, or C. Okay. And the cash flow, let's write it down. For minus 1 indicates -1 means that at that time we can do investment. So -1 for 0 and for time 0 means that we can invest A and or C. We cannot invest B in time 0. Okay? So it means that the 0 indicates I cannot invest B at period 0 or time 0. Okay? And the rest of the periods, we have some dollars. 1.5, 0.2, 1.5, 0.5. So it means that I invest 8 in time 0. I will get return 0.2 in period 1. Get return 1.5 in period 2. My revenue. Okay? And investment B in period 1, I will get my return at time 3 for $1.9. It means that I invest $1 in time 2. In time 1, I will get $1.9 at time 3. Okay? Our goal is to try to maximize the money, the total money, in the end of period 3. Okay? Take a break. We'll continue to talk about it.